Welcome to Praveen Patil College of Diploma Engineering and Technology, our department Humanity and Science. Subject obviously Applied Mathematics. Name of faculty Mrs. Smita Shekhar Kamble. In today's lecture we have to discuss about application of derivative chapter number 3. Application of derivative, it is the advantages of the derivative we concerned in the last lectures. What is derivative? Derivative represent the function addition, multiplication, division, subtraction, that is f dash of x is equal to limit h tends to 0 t plus h minus f of t upon h, that is increasing value we have to define. We know that tangent and normal. In this diagram we have to see this one is obviously normal and this one is tangent which touches the circle at the one point only. Definition: let P be any point y is equal to f of x. Q is another point close to P. Limiting position of the PQ as approaches P is called tangent to the curve y is equal to f of x at the point T. The tangent is the straight line which touches the curve at exactly one point that it is represent. The normal is the line passing through the point P and perpendicular to tangent PT. Just we have to introduce. Now our target is to define dy by dx is what? Let Px comma y and Qx del x plus y plus del y be the two neighborhood points on the curve y is equal to f of x. Let PQ makes an angle theta with x-axis and the tangent PT at P makes an angle with the x-axis, that is psi angle. Normal curve we have to discuss and we have to use the slope of tangent to the curve y is equal to f of x at x1 comma y1 is m is equal to dy by dx at the point x1 comma y1. Slope of normal is minus 1 upon m. The equation of tangent to the curve y is equal to f of x at x1 y1 is y minus y1 is equal to mx minus x1, where m represents the derivative with respect to that point. The equation of normal y is equal to f dash of x at x1 y1 is y minus y1 is equal to minus 1 upon m x minus x1, where m represents the slope of tangent, where it is 1 upon m that represents the slope of normal, which is the derivative. Find the slope of tangent to the curve y is equal to x cube at the point where x is equal to 1 upon 2. What is given? Y is equal to x cube is given. Dy by dx is equal to 3x square is there. We have to use the derivative formula. I use here pen. We have to use the derivative formula, that is derivative of x raised to n is n x raised to n minus 1. That's why here x cube derivative, it is obviously 3x square. Here n is 3x raised to 3 minus 1. Slope of tangent m is equal to dy by dx as x is equal to 1 upon 2. The point is given. We have to put the value of x square as 1 upon 2 bracket square. 1 upon 2 bracket square 1 upon 4. Final answer m is equal to 3 by 4. In this way, we have to find the slope of tangent to the curve at the point where x is equal to 1 upon 2. Find the slope of tangent to the curve y square is equal to 4ax at 80 square 280. Be careful, here the equation is given. So obviously we have to consult as here it is the x1 and y1 point. That is 80 square and 280. We have to consider the equation y square is equal to 4ax. Y square derivative, we have to represent the derivative of y term is what? Derivative of y is 1 but dy by dx. So it is applicable the derivative of y square. We know that derivative of x square is 2x. So derivative of y square is 2y but dy by dx. 4ax. 4 and a are constant. Derivative of x is 1. So dy by dx is equal to 4a upon 2y. 2 2's are 4. That's why 2a upon y. Now slope of tangent. We have the formula m is equal to dy by dx at the point 80 square comma 280. We have to put 2a remain as the same. Y is equal to 280. 2a, 2a get cancelled. 1 upon t is remaining. So we define the slope of the tangent to the curve y square 4x at 80 square comma 280 is 1 upon t. Find the slope of tangent at 1 comma minus 2 on the curve y is equal to x raised to 4 minus 3x square. Here we have to represent x and y is the point 1 comma minus 2. Y is equal to x raised to 4 minus 3x square. So dy by dx is equal to 4x square. We have to use the formula derivative of x raised to n is what? N x raised to n minus 1. In this way, x raised to 4 derivative 4x cube minus 3 remain as the same, x square derivative 2x. Simplify 4x cube minus 3 2's are 6. 4x cube minus 6x. So dy by dx is equal to 4x cube minus 6x. Slope of tangent m is equal to dy by dx at the point 1 comma minus 2. We have to put the value of x. X is 1. 4 1 cube minus 6 into 1 4 minus 6. So m is equal to minus 2. Therefore, the slope of tangent at 1 comma minus 2 on the curve y is equal to x raised to 4 minus 3x square is m is equal to minus 2. Find the slope of normal to the curve y is equal to x square plus 7x at the point 1 comma 8. Again we have the point given in the form of x comma y. So we have to consider the equation y is equal to x square plus 7x dy by dx. What is the derivative of x square? Yes, it is 2x. We have to use which formula? Yes, that is derivative of x raised to n is what? N x raised to n minus 1. So that's why derivative of x square 2x, derivative of 7x, that is 7 into 1. 2x remain as the same, 7 remain as the same, dy by dx is equal to 2x plus 7. We know that slope of tangent m is equal to dy by dx at the point 1 comma 8. We have to put the value of x here because y is not available. So 2 into 1 plus 7, it is 9. But slope of normal we have to find. So we have formula minus 1 upon m. We have to put the value of m in denominator. So we derive minus 1 upon 9 is the slope of normal to the curve y is equal to x square plus 7x at the point 1 comma 8. At what point does the curve x into y, x minus y minus 4 cuts the x-axis? What it happened? On x-axis, y coordinate is 0. Be remember that. So, we have to use that condition given that x into y is equal to x minus 4. So, when the cuts curve the axis, then put y is equal to 0 in equation 1. If we put y is equal to 0, then we derive the 0 into anything is 0. So, 0 is equal to x minus 4. So, x minus 4 equal to 0, that represent x equal to 4. So, required equation of the point is equation of the curve have the point 4 comma 0 because y coordinate is 0. We have to find a and b with the example. We have to have 2y cube is equal to ax square plus b. It is the equation. So we have to differentiate with respect to x to both sides. We know that derivative of y cube is 3y square. So we have the formula of derivative. I explain here with using pen, that is derivative of x raised to n is what? N x raised to n minus 1. So in this way, y cube derivative 6y square dy by dx, ax square derivative 2ax and constant derivative is 0. So equating part 6y squared divided by this way. So we have dy by dx is equal to 2x upon 6y square. But 2 3s are 6. So 2 1s are and 2 3s are 6. We derive ax upon 3y square. Given part 1 minus 1 is given. So dy by dx is equal to a into 1 3 minus 1 square. A upon 3. We have x plus y is equal to 0. We have to put the x value is 1, y dy by dx is equal to 0. dy by dx is equal to minus 1. So a upon 3, the slopes are equal. A upon 3 is equal to minus 1. So a is equal to minus 3. So we have to put the value of a is equal to minus 3 in above expression. 2y cube is equal to ax square plus b. So we derive the value of b here. How? Minus 1 cube is minus 1 into 2 minus 2. A into 1 square is a. We have the a value is the what? Minus 3. So minus 3 plus b. Simplify, b is equal to 1. In this way, we derive the value of the given example using the derivative. Most useful, in previous lecture we have to discuss about the equation of tangent and normal. My question, what is the tangent and normal? Derive the equation of tangent and normal to the circle at point. Here, a tangent to the circle is a line what touches the circle at point. Normal to the line which is perpendicular to the tangent passing through the curve. In this way, it is normal and it is the tangent. It is easy to understand. The tangent line equation is y minus y1 f dash of x1 x minus x1, where f dash of that represent here, that is important, I highlight here, m is equal to dy by dx, that is f dash of x. So we have to write y minus y1 is equal to m in bracket x minus x1, where is m is the slope which is derivative. Now normal equation, y minus y1 is equal to minus 1 upon f dash of x1 minus x minus x1. Here also we have to reduce and simplify the equation in terms of minus 1 upon m x minus x1. These are the tangent equation, that is equation of line, that is y minus y1 is equal to m x minus x1, and the equation of normal to the line y minus y1 is equal to minus 1 upon m x minus x1. We have to take the example based on this. Find the equation of tangent at the point 1, 1 on the curve x square plus 2y square is equal to 3. It is implicit function. We have to take the derivative with respect to x to both sides. That is the important. So that's why we have to take the derivative of x square is 2x. 2 remain as the same. Derivative of y square is 2y dy by dx. And derivative of 3 is 0 because derivative of constant is always 0. So divided by 2, we have to take the common 2, x plus 2y dy by dx equal to 0. So dy by dx is equal to x goes this side, so minus x upon 2y. So it is the derivative. We know that the slope of the dy by dx is equal to minus 1 upon 2. So the equation of tangent is given by y minus y1 is equal to m in bracket x minus x1. We have the equation of the m, we have to derive, that is m is equal to minus 1 upon 2. So obviously 2 into 2y, 2 minus 2, minus 1 into x, x, and minus 1 into minus 1 plus 1. Equating part start, we have to shift x this side. So x plus 2y and minus 2 minus 1 minus 3 is equal to 0. So x plus 2y minus 3 equal to 0, the equation of tangent. So in this way, we have to derive the equation of tangent to the at the point 1, 1 on the curve x square plus 2y square is equal to 3. Find the equation of normal to the curve y is equal to 4x minus 3x square at 2, minus 4. Again we differentiate with respect to x to equation of the curve normal. Dy by dx is equal to 4a into 1, x derivative is 1, x square derivative 2x, so simplify 4 minus 6x. the slope of